Welcome to America Reads Fun Learning Activities, where college students make learning activities for kids. Our activities focus on reading, writing, and math. Thank you for choosing to learn with us today. My name is Rachel, and our activity will be focusing on scientific notation. Let's get started.
You may have asked yourself, what is scientific notation? Well, one definition of scientific notation is that it's a way to express a number that is large or small into a different form that is more convenient by using less digits. So how does scientific notation use less digits? Well, it will always follow the form of some number that is in the ones times 10 to the power of some number. Let's look at an example with the number 100. So remember the form of scientific notation, where we have a number in the ones place multiplied by 10 to some power. So what do you think the number in the ones place that we will be using for the number 100? So let's take a look. With 100, we have a decimal here. If we were to move this decimal over 1, that would be the same as dividing 100 by 10. If we were going to move the decimal over one more time, that would again be dividing by 10, and we would get the number 1. Number 1 is in the ones place. So we can see that by dividing 10 two times, we were able to get the number 1. This 1 will go into our ones place. Now, since we divided by 10 two times, to get the number 100, which is the number that we are representing in scientific notation, we will be multiplying by 10 two times to undo that division. And so 10 times 10, another way of writing that is 10 to the second power. And so in scientific notation, 100 would be 1 times 10 to the second power, which is equal to 100. Let's take another example. Let's look at how the decimal moves in relation to finding our exponent. And so we had the number 100, and we moved our decimal point 2 times to the left. And so it's important to know is that what direction did you move your decimal point in? To the left or to the right? And then how many times did you move that decimal point? So in our case, we moved it 2 times, and we moved it to the left. Left lets us know that our exponent is positive. And the number of times lets us know the value of our exponent. And so we have the number 100. We move the decimal point to the left 2 times, have the number 1. And so we have 1 times 10. Move the decimal 2 times to the left, positive exponent. 2 is our value, so 10 to the second power. And this equals 100. Let's look at another example, the number 1/1000. So first we need to find the number that we will put in the ones place that we will be multiplying by 10 to some power. So the best way to approach this is to think about where you're moving the decimal and how many times you're going to be moving the decimal over. So in this case, we want 1 in our ones spot. So we're going to move the decimal over 1, 2, 3 times to the right. And then 1 will be in our ones place. And now we need to figure out, okay, what power are we going to use? Let's look at another example, the number 1/1000. So remember how in the last example we multiplied by 10? Let's look at another example, 1/1000. Remember in the last example how we divided by 10 to get 100 down to a number in the ones? Well, in this case, we're working with a small number, and we're going to need to multiply by 10 to get the fraction to the ones place. And so if we take 1/1000 times 10, that actually ends up moving the decimal place 1 place to the right and gives us 1/100. Now let's do the same thing again. Since we have our 1 in the hundreds place, we want to get our 1 to the ones place. So we're going to multiply by 10 once more. And this again will move our decimal place 1 to the right, and we get 1/10. Now we just need to multiply by 10 one more time to get our ones to the 1 place. And then we get the number 1. So this 1 is what goes in the ones place for our scientific notation. But now we need to see what number here are we going to be multiplying by. So in this case, we multiplied by 10 to get 1. But we want to have our scientific notation represent 1/1000. And so to undo the multiplication we did, we're going to be dividing by 10. And so if we look at 1/1000 and follow where the decimal place went, we went 1, 2, 3 to the right. And this tells us that our exponent will be -3. So now that we found our ones place, we need to find now the exponent of the 10 that we are multiplying 1 by. And so if we look at what we did, we multiplied by 10, we multiplied by 10, and then we multiplied by 10. So we multiplied by 10 3 times. So the opposite of multiplying by 10 3 times would be dividing by 10 3 times. And so the opposite would be dividing by 10 3 times. So 1 divided by 10 is actually the same as 10 to the -1. And so if we were to do this 3 times, our exponent would be 10 to the -3. Another good way to look at this is to follow where we moved the decimal. So we moved our decimal 1, 2, 3 to the right. And so we want to look at direction and the number of times that we move the decimal. And so we move to the right, and right will always tell us that our exponent will be negative. and then we moved to the right 3 times. This is the value of our exponent. And that's how we got -3 as our exponent of 10 that we multiply by the number in the ones place. Let's look at a real-life example of a value where we can use scientific notation. So the estimated age of the Earth is 4.5 billion years. Remember our form for scientific notation? A number in the ones times 10 to some raised to some power. Remember how we move the decimal point and we look at, is the decimal point moving to the left or to the right? And how many times did we need to move that decimal point? And so we have our imaginary decimal point right here, and we want to get a number in the ones. So we'll end up moving this decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 times to the left. 9 times to the left. And so left tells us that our exponent is positive, and 9 tells us our value. And so our exponent is going to be 9. And so our exponent is going to be 9. And when we look at the number we get here, we get 4, which is in the ones. Rest of that is going to be behind the decimal, and so we get 4.5. And so this is our value in the ones, 4.5 times 10 to the 9th. Now let's look at a real-life example of a small number. So the length of a dust mite is about 0.0003 meters. And so again, let's move our decimal so that we have a number in the ones place. And then we'll look at the direction that we move the decimal point in and how many times we moved it to find what our power is going to be. And so if we move this decimal point 1, 2, 3, 4 to the right, so 4 to the right, that gives us the number 3, which is a number in the ones place. And so 3 is our ones place, and we moved it 4, which is our value of our exponent, and to the right, which lets us know that our exponent is negative. And so our exponent is going to be -4. And that will go right there. So our final answer will be 3 times 10 to the -4. So now let's take a look at how scientific notation makes it easier to compare values. So the first thing to check when you're trying to rank is, are your exponents negative or positive? So here we see we have -4 and -3. So that tells us that one of these two is the smallest number. We see that -4, the number 4 is larger than 3, which means that our decimal point is going to be moving 1, 2, 3, 4 to the right. Whereas in this, it's going to be moving. With the value 4, that shows us that our decimal is going to be moving 1, 2, 3, 4 to the left. But with this one, it's going to be moving 1, 2, 3 to the left. So moving the decimal 4 times to the left will give us a smaller number than moving it 3 times to the left. So 3 times 10 to the negative 4, which is the length of a dust mite in meters, is going to be smaller than 1 times 10 to the negative 3. Next, let's look at our two values where our exponents are positive. So we're going to look at the same thing here. Which exponent will end up moving the decimal more? So 9 tells us 1's value. We're going to be moving the decimal 9 times to the right. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. And fill in the zeros. So this gives us 4.5 billion, which is the estimated age of the Earth. Now let's look at our other example. We have our value that's in the ones place, 1. And then we have the decimal moving 2 times to the right. So 1, 2. Fill in the zeros. This is a value of 100. So 4.5 billion is much bigger than 100, and so 100 will be in third because it's smaller, and then 4.5 billion will be last because it is the largest number. Now you try. Linked in the description below is a worksheet to practice scientific notation. Thank you for learning with America Reads today. That is all for today's lesson. We hope you come back and learn more. Please comment if you have any questions, like and subscribe to our channel, and we will be back with more videos soon.